right? We are now at 3.2, the laws of indices. Okay, so basically we will be learning for this week. There will be 5 laws, okay, which we'll be learning for now. Okay, but so we'll be learning them step by step. Okay, so we'll wait. Okay, and then let's look at page 60. Okay, we look at page 60, right? Okay, we're going to try to derive the first law. Okay, I will write down the first law first. Okay, a to the power of m times a to the power of n is equals to a to the power of m plus n. Okay, so as of now it doesn't make much sense. Okay, so let's try to make sense of it. Let's do the investigation first. Okay, so why not you carry out the investigation first on your way. Okay, so from the investigation, what do you find out? Okay, you find out that 7 to the power of 2 times 7 to the power of 3, the answer is 7 to the power of 5. Okay, so there's this connection, the 2 plus with the 3, you will get a 5. Okay, and it happens for all the investigation. Okay, so why is this so? Okay, so let's work with this. Okay, when we get a to the power of, let's say, 4, okay, when we multiply to a to the power of 3, we can actually break it up. This a to the power of 4, we can write it as a times a times a times a. There is 4a over here, and then after that for 3, again a times a times a. That's 3. So the equation nicely put into 7 a's arranged and they are multiplied together. Okay, so we can combine them, become a to the power of 7 for this case. Okay, so from here we arrive at the first law, which is a to the power of m multiplied by a to the power of n, okay, is equal to a to the power of m plus n. Okay, when the base is the same and we multiply, okay, we add up the powers. Okay, so that's law number 1. Okay, so I'll now move on to law number 2. Alright, so welcome back. We are going to do law number 2 now. Okay, so for law number 2, it will be on page 92. Sorry, page 62. Okay, so page 62, they say that a to the power of m divided by a to the power of n is a to the power of m minus n. Kind of similar to the first one, but slightly different. Okay, so to understand this, I need you to try investigation, the one at the top on page 62. Try that investigation first, okay, then I'll come back. Alright, so for investigation, right, okay, let's look at the second question. Okay, 10 to the power of 6 divided by 10 to the power of 4. Okay, so divide, you can also write it as fraction, right? Okay, so there's a reason why we write it as a fraction instead of just writing as divide. Okay, because it helps us. Okay, for 10 to the power of 6, we write it as 10 times 10 times 10, 6 times. Okay, and then okay, what we'll do is we divide it by 10 times 10 times 10 times 10 4 times. Okay, for the one in the denominator. Okay, but when we write it like this, we know that in fraction, whenever we have identical terms like this, okay, we can actually cancel them. Okay, so we can cancel one of this, one each, one each, one each, and we are left with 2 at the top. Okay, so this tells us that this is actually 10 squared, okay, which happens to be 6 minus 4. We get 2. Okay, so that is why when a to the power of m divided by a to the power of n, okay, when the base is the same and then we want to divide those two numbers, okay, all we have to do is keep the base and then we subtract the powers. That means m subtract with n. Okay, so that is law number 2. Okay, so before we move on, I need you to try practice now 1, okay, and also practice now 2. Okay, because these two, the laws are the same, so we do together, and then after that we'll do the practice now 1 and practice now 2. Okay. Right, for this one, we are now at indices law number 3. Okay, law number 3 is slightly different. If you look at law number 1 and number 2, okay, they both involve like at least two terms. Okay, but for law number 3, there's only one term involved. Okay, so it's just one of the base, A, for example. Okay, A to the power of m, and then we bracket, and then we put it to the power of n. Okay, we continue. So they say that it becomes A to the power of m n. Okay, so to understand this, okay, let's look at the investigation on page 63. Okay, so we start with number 1. Okay, number 1 looks easy. So 2 to the power of 5. Okay, to the power of 5, and then you square. Okay, so what's the meaning of this is when you say you want to square a certain number, okay, that means that number gets multiplied by itself, like this. Okay, so when we arrive at this, we realize that we are now doing something that is similar to law number 1. Can you see that the base is the same? Okay, law number 1, the base is the same. Okay, and then after that, the power we have to add them up. Okay, from what we learned in law number 1, the power we add them up. So it will become 5 plus 5 is 10. So this becomes 2 to the power of 10. Okay, which is actually, coincidentally, 5 times 2. Okay, so from here, we learned that when it's a single base, and then we have an indices here, and then we want to bring it to the power of another number, all we have to do is multiply the two indices. Okay, so that means now it becomes A to the power of m, and then we raise it to the power of n again. Okay, that is A to the power of m times n. Okay, so this is law number 3. Okay, right. So for this one, you will have to do the practice now 3 first. Okay, and then after that, we'll carry on with law number 4. Okay, so try practice now 3 first. Alright, so now we're back. We are going to do law number 4 now. Okay, so law number 4 states that A to the power of m multiplied by B to the power of m is equals to AB multiplied together, and then both in bracket to the power of m. Okay, notice law 4 and law 1, they are different. Okay, you notice that I purposely used blue paint for this one, okay, because for law 1, the base is the same, A, E. But for law 4, right, the base is not necessarily the same. Okay, so it's A and B. But the indices is the same. Okay, so the index here is M, the index here is M. Okay, then you can use law 4. So law 4 deals with similar powers. Okay, so let's try to make sense of it. So for that, you have to look on page 64, the investigation. Okay, so I'll leave it to you to try out the investigation first. Okay, so for now we need to go through the proof. Okay, why is this true? Okay, so I'll look at question 3, but I will not be using n. I will be using numbers, so it will be clearer on your end. Okay, so let's try A to the power of 3 multiplied by B to the power of 3. Okay, so similar to the previous one, we can break it up into A times A times A. Correct? Okay, for the B, we multiply it as B times B times B. Okay, but the thing is, other than like grouping them like this, we can actually group them because these are all multiplication. Okay, in multiplication, we can multiply in any order. We don't have to follow strictly from left to right, etc. Okay, so I can basically group A times B. Okay, and then I bracket it first for certain reason, and then I multiply again, but with another group of A times B. So let's say this one is for the first group. Okay, and this one is for the second group. Okay, but we have another pair over here, A and B. Okay, so for the third group, we make another pair. Okay, so we have 3 sets of A times B A times B, A times B, and then we multiply them again. Okay, so if A times A times A is A cubed, B times B times B is B cubed. So if AB, this AB, right, when we times this AB, AB times AB times AB is AB cubed. Okay, so if you compare, okay, if this was a 3 and a 3, okay, A cubed times B cubed is AB cubed. Okay, so if A to the power of M, because the 3 can be any number, so A to the power of M times B to the power of M is AB to the power of M, and that is law 4. Okay, so I need you to hold on first. We don't do the practice now. We'll wait until law 5, then we'll do the practice now. Okay? Alright, for law 5, let's take a look at the page first. Okay, law 5 is on page 66. Okay? Right, so at the bottom over there. Okay, so over here, okay, law 5, A to the power of M divided by B to the power of M. Okay, again, the base is not the same. Okay, it's something like law 4, but we are going to change it to divide now. And then this is A over B to the power of M. Okay, so we'll jump straight to the proof for this one. Okay, since you are comfortable with it already. Okay, so we have our A cubed divided by B cubed. Okay, so that's how we did our law 2, right? When we do divide, we change it to fraction. Okay, but for the numerator, we'll be dealing with A cubed. So it's A times A times A. This is your A cubed. Okay, for the B, we write it in the denominator because it's divide, right? So it's B times B times B, which stands for the B cubed. Okay, right. This is one way of writing. Okay, we combine them as one fraction. Okay, let's do the same way like this. We group them up, but we group them in different fractions. So A over B. Okay, we know that all this involves times, right? This is the same as A over B multiplied by another set of A over B multiplied by another set of A over B. Okay, we know we can do this because the operations involved here are all multiplication. Okay, so we can separate them up into this way. Okay, because when this times out, right, we times all the numerator together. Remember in primary school, right? Okay, when you multiply fractions, the numerator multiplied by numerator, denominator multiplied by denominator. So when you times this, is A times A, and then times another A. So A times A times A. So it's okay, it holds. B denominator times B denominator times B denominator. So it's B times B times B. So we didn't disobey any of the law, okay, when it comes to the multiplication. Okay, but when we do this, is 3 sets of A over B. So similar to what we did just now, this one is actually A over B, but because it's 3 sets and being multiplied, so it's A over B cubed. Okay, so this is our law 5. A to the power of M divided by B to the power of M is A over B. Okay, divide, right, and then to the power of M. Okay. Okay, so now you have learned law 4 and law 5. They are quite similar, so I need you to try practice now 4. Okay, for the law 4, and then practice now 5 on page 67. Okay, practice now 4 is on page 65, and then practice now 5 is on page 67. Okay, so I need you to try those two. Okay, and once we are done, your homework will be please look at page 68. Okay, so I will be flashing out the homework questions in this week.